we have quite a few compounds based on carbonyl group. Carbon double bond oxygen. Carbon and oxygen double bond is a very, very stable structure, which is why it's extremely reactive, because you have a very polarized bond. The oxygen is pulling, really pulling from the electrons from the bond. So in one hand, that makes it very reactive. But on the other hand, it's very stable, because carbon and oxygen are roughly, they are next to each other in the periodic table, they are similar size, that double bond really makes it very stable. And in many chemical reactions, in many chemical and biochemical processes, the carbonyl group will break off temporarily and then will be reformed. And that is why there are so many functional groups that have a carbonyl group, this carbon double bond oxygen in the structure. You have aldehydes and ketones, in which you have the carbonyl group either at the end of a chain, what they call a terminal one, and you have an aldehyde, or in the middle of two carbons, and then you have a ketone. One of the most famous ketones is acetone, and this is the structure of acetone. It has 3 carbons. Propanone is also called, but the common name is widely known. 3 carbon atoms in the carbonyl group there in the middle of those 3 carbon atoms. They are strongly polar, again, because you have this pull between of the oxygen from the electrons that shares with the carbon, and they tend to be soluble in water because they are polar compounds, and water is a polar solvent, so they, like dissolves like. They are very fragrance compounds. They can have quite a pleasant or strong odor and a pleasant odor, and in many cases the smells that you associate with pears, apples, vanilla, cinnamon, almond are actually aldehydes or ketones. So they can be very volatile. That means that they evaporate very easily and they have a strong smell, and in general a pleasant smell. And as I mentioned, one of the most common ones, the ketones, so the most famous one is acetone, used as nail polish remover. Carboxylic acids have as functional group the carboxylic group. Carboxy group, carboxylate, you could see it, carboxylate. You will see name in slightly different ways, but we refer to this group, this carbon, double bond oxygen, and another oxygen attached to hydrogen, and the rest of the molecule. They're always what we call terminal groups. They are at the end of the chain. So, the chain can only grow on this side. And they tend to, they have proper established names depending, with the ending oic acid. So methanoic acid with 1 carbon atoms, ethanoic acid 2 carbon atoms, pentanoic acid 5 carbon atoms. Having said that, most of them have common names. So formic acid, which is methanoic acid, and they tend to be names, in general, Latin names, and they're associated from where they were first extracted. So formic acid is methanoic acid, acetic acid, which is, vinegar is a diluted solution of acetic acid in water. Propanoic acid is typically called propionic acid. Butanoic acid is typically called butyric acid because it was first isolated from a butter, which can be a bit confusing. And the key characteristic is that they are weak acids. This hydrogen here that they can lose. So an acetic acid is a typical example of a weak acid. So they're all weak acids, and they are able of losing that hydrogen as a hydrogen ion. Amines, or amines if you prefer to call them like that, are when you have a nitrogen in your structure, a nitrogen with single bonds to carbon. And you could imagine them as a derivative of ammonia. So instead ammonia, which is NH3, so instead of having 3 hydrogen atoms, you have at least 1 carbon. And you might have heard the word primary, secondary, tertiary amines. And that means how many carbon atoms they have attached to them. So primary amines, they only have one carbon atom. Secondary amines, they have two carbon atoms attached to them. And tertiary amines, all the bonds to the nitrogen are carbons. And they are weak acids. As ammonia is a weak acid. Sorry, they are weak bases. As ammonia is a weak base, well, amines are also weak bases, and they dissociate in water and they liberate hydroxyl ions. They are what we call Lewis bases. If you remember your acid-base chemistry, it means that they have electrons that they can donate, that they donate to the water to capture this hydrogen ion. You might have heard about the word alkaloids, and some of them have really bad press: amphetamine, cocaine, heroin, nicotine. Well, they are all amines, and because they are basic compounds, they are alkaline compounds. Natural amines are typically called alkaloids. So when people talk about alkaloids, they are talking about amines, naturally occurring amines. And the last couple of functional groups I want to talk to you about: carboxylic acid derivatives, esters and amides. When you react a carboxylic acid with an alcohol, you lose a molecule of water and you end up with an ester. And here you've got, again, the carbon double bond oxygen and the other oxygen, but it's attached to a carbon rather than to a hydrogen. And if you react a carboxylic acid with an amine, it's not the only way of making both of them, but it's a way that you might conceptually think, this is how I make an ester, this is how I make an amide. If you react a carboxylic acid with an amine, you get an amide. And you've got here what an amide is, in which you have lost, again, a molecule of water, and you end up with the nitrogen attached to that carbon of the carbonyl group. And the reaction, can go one way, but you can also revert it. They can also easily be what we call hydrolyzed, broken down into their original constituents in both cases. Esters are slightly finicky to name because the name consists in two words. One word that reminds you what the alcohol they came from, and the other name that reminds you of what acid they came from. The key message here is that when you say this O8 or this 8, an acetate, an propionate, butanate, anything that ends at like 8, that means that compound is an ester. And the first word, in this case, a methyl group, tells you, oh, that's the alcohol part, that's the bit that comes from the alcohol. But if only remember that, the 8, an ending of 8 in an organic compound indicates that compound has an ester. And amides drop, again, the oic from a carboxylic acid, and it replaces it with the name amide. So every time you see the word amide, acetamide or propanamide, that means you're looking at an amide, that carbon double bond oxygen and bonded to a nitrogen. And sometimes your nitrogen will be substituted, and you will see letters appearing in your name, and that means the name is telling you what are the two substituents that are hanging from the nitrogen. In this case, two methyl groups. And the last word about amides: in a biochemical environment, in a biological concept, the amide bond is actually a peptide bond. So the most famous natural amides that there has ever been are proteins, which are made of a group of amino acids attached together with a peptide bond, which is an amide bond. So this is all from me. I hope it was useful. There was a lot to cover in these videos, but I hope that it has given you a little bit of an indication of the language that you use when you're talking about organic compounds, and hopefully will help you feel more comfortable to decode when you see an organic name, when actually that name is telling you how much information is giving you by those random combination of prefix and numbers and letters, etc. So I hope this was useful, and thank you for watching.